U.S. military's hypersonic missile, Conventional Prompt Strike, CPS, is maturing well. A Department of War statement noted, the U.S. Army's Portfolio Acquisition Executive Fires, in partnership with the U.S. Navy's Portfolio Acquisition Executive Strategic Systems Programs, conducted a successful launch of a common hypersonic missile from Cape Canaveral Space Force Station, Florida, on March 26, 2026. The Army and Navy partnership to field a common hypersonic missile across land and sea-based platforms supports the national defense strategy by accelerating timelines, reducing costs, and delivering a highly survivable capability to defeat time-sensitive, heavily defended, and high-value targets at speeds exceeding Mach 5. In this video, Defense Updates analyzes why successful test of Conventional Prompt Strike missile is an important milestone. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. Conventional Prompt Strike, CPS, is a non-nuclear hypersonic weapons concept based on an intermediate-range boost glide architecture. The system comprises a two-stage, solid-fueled booster that propels the payload to extreme altitude and velocity, coupled with the Common Hypersonic Glide Body, CHGB, which carries and delivers the warhead. The U.S. Department of Defense has developed the CHGB as a standardized hypersonic payload intended to support multiple offensive strike platforms. Rather than pursuing separate glide vehicle designs for each service, the Pentagon adopted a common architecture adaptable to both the U.S. Army and the U.S. Navy, with the Navy designated as the lead service for glide body development. The CHGB's design builds upon earlier hypersonic research programs. Its technical lineage can be traced to the alternate reentry system, flight tested in the early 2000s under the Army's Advanced Hypersonic Weapon Initiative. That program, in turn, evolved from the Sandia Winged Energetic Reentry Vehicle Experiment, SWERV, a prototype developed by Sandia National Laboratories in the 1980s. To enable joint service integration, the glide body's physical dimensions and interface standards have been harmonized across platforms. In a CPS launch sequence, the booster lofts the glide vehicle along a ballistic trajectory to high altitude. Following separation, the glide body re-enters the atmosphere and proceeds toward its target at sustained hypersonic speeds, maneuvering within the upper atmosphere rather than following a predictable ballistic path. Hypersonic flight is generally defined as speeds exceeding Mach 5, over 5 times the speed of sound, approximately 1,715 meters per second, 3,836 miles per hour, or 6,174 kilometers per hour. Unlike traditional ballistic warheads, the CHGB capability of in-flight maneuvering enables it to adjust its trajectory and complicate interception. It is also significantly faster than conventional cruise missiles. This combination of speed and maneuverability presents substantial challenges for existing missile defense systems, none of which are currently optimized to reliably counter such threats. The CHGB will be integrated into service-specific delivery systems across the U.S. military, including both land-based launchers and naval platforms like Zumwalt-class warships. Within U.S. strategic doctrine, CPS is intended to provide a rapid, long-range conventional strike capability against high-value targets, offering a credible non-nuclear option for deterrence and prompt response. According to available reports, the test forms part of a broader Pentagon initiative aimed at accelerating the deployment of advanced technologies for operational use. On November 17th, the U.S. Department of Defense identified hypersonic weapons as one of 6 critical technology areas, CTAs, deemed essential for maintaining a decisive battlefield advantage. The 6 areas include applied artificial intelligence, AAI, biomanufacturing, BIO, contested logistics technologies, LOG, Quantum and battlefield information dominance, QBID, scaled directed energy, SCADE, and scaled hypersonics, SHY. All of these initiatives are directed toward enhancing battlefield performance. At the time, Secretary of War Pete Hegseth underscored that the nation's military has long remained at the forefront of global military power. He stated, Undersecretary Emil Michael's 6 critical technology areas will ensure that our warriors never enter a fair fight and have the best systems in their hands for maximum lethality. According to the United States Department of Defense, the effective transition of innovation into operational capability will be central to securing future dominance. Hegseth further noted, the War Department is committed to remaining the most deadly fighting force on planet Earth. One of the most critical implications of CPS lies in deterrence dynamics. Hypersonic weapons enable rapid, high-precision strikes against time-sensitive and heavily defended targets, such as command and control centers, air bases, and missile launchers. From an operational standpoint, hypersonic missiles provide the U.S. military with a means to penetrate increasingly sophisticated anti-access area denial, A2AD networks deployed by China and Russia. These networks rely on layered air defenses, electronic warfare, and long-range missile systems to keep U.S. forces at bay. Hypersonic weapons can bypass or overwhelm such defenses, restoring the U.S. ability to project power into contested regions. In this sense, they are not merely offensive tools, but enablers of broader joint force operations. Another key factor is the evolving nature of strategic competition. The urgency for the United States is driven largely by the pace of Chinese and Russian development. Both countries have already fielded operational hypersonic systems, with Russia deploying weapons such as the Kinzhal and Zircon, and China integrating hypersonic glide vehicles into its missile forces. In contrast, the U.S. has faced testing delays and slower deployment timelines, creating what analysts describe as a growing capability gap. This asymmetry risks undermining the long-standing technological superiority that underpins U.S. global military dominance. Moreover, the hypersonic race is as much about signaling and credibility as it is about battlefield utility. Military power in the 21st century is closely tied to perceptions of technological leadership. Falling behind in hypersonics could weaken U.S. alliances, particularly in regions like Europe and Asia, where partners rely on American capabilities for security guarantees. Conversely, demonstrating credible hypersonic capabilities reassures allies and reinforces deterrence against adversaries.